So I'm continuing my video session for 5070, and this time I've selected the variant 41. It's of May, June 2025. Paper 4, it's alternative to practical. The total time is 1 hour. We have to answer all the questions on this paper. I'm not going into details of, for the instruction and information, as you all are aware that total mark for this paper is 40. Important thing in this paper is that you will be provided with the notes for use in qualitative analysis like this. This will include tests for anions, cations, tests for gases, as well as flame tests. So here's question number 1. The student determines solubility of solid ammonium chloride in water at 60 degrees centigrade. The student, step 1, puts 100 centimeter cube of water into a beaker. Each water measures the mass of a weighing bottle containing ammonium chloride. Adds some of this ammonium chloride to the water. Fills the mixture to dissolve the solid. Repeats steps 4 and 5 until a small amount of undissolved solid remains in the beaker. Measures the mass of the weighing bottle and unused ammonium chloride. Calculates the mass of ammonium chloride added to the water. Number 1. State 1 extra measurement the student must make to calculate the solubility. Definitely, you need to measure the water temperature to make sure that's 60 degrees centigrade. Measure the water temperature to make sure that it is 60 degrees centigrade. Number 2, the student's results are shown in table 1.1. So we have initial mass and final mass. Use the results to calculate the solubility of ammonium chloride at 60 degrees centigrade in gram per dm cube. Now they are asking us to calculate the mass, dissolved soluble mass in gram per decimeter cube. You know that 1 decimeter cube is equal to 1000 centimeter cube, and the mass they have dissolved in 100 centimeter cube of water. So what I'm going to do, first of all, I'm going to find the mass that is dissolved in 100 centimeter cube by subtracting 115.5 from 173.7. So we'll get 173.7 minus 115.5, 58.2 grams. This will be the mass that's dissolved in 100 centimeter cube. 100 centimeter cube dissolves 58.2 grams. Therefore, 1000 centimeter cube dissolves X gram. So X is equal to 58.2 multiplied by 1000 divided by 100. So final answer will be 582 grams per decimeter cube. Move to next part, which is part 3. Explain why the method the student uses gives a higher value for the solubility than the true value. Definitely, some of the solid does not dissolve. That's we are getting why is getting the higher value, because some of the solid did not dissolve. Part B. The student repeats the experiment at different temperatures. The results are shown in table 1.2. So we have solubility in gram per decimeter cube at 0 degrees centigrade, 40 degrees centigrade, and 80 degrees centigrade. Estimate the solubility of ammonium chloride at 20 degrees centigrade. 20 degrees centigrade must be between here, that is between 0 and 40. If you see the difference between the solubility for each, that's between 0 to 40 and 40 to 80, it will be 180. So what I'm going to do, I'm going to divide it by 2 and I will get 90. So simply add 90 to 300 to get the solubility at 20 degrees centigrade. So 390 degrees centigrade will be the 390 grams. Sorry, 390 grams per dm cube will be the final answer at 20 degrees centigrade. So student also wants to measure the solubility of ammonia. Suggest why the method used for ammonium chloride is not suitable for determining the solubility of ammonia. Ammonia is a gas. You can't weight gas on a balance.
Welcome to Chain of Qualified Tutors. Unlock your academic potential with expert tutoring, from secondary school to graduation level. Master math, science, English, and more with personalized one-on-one guidance. Call or WhatsApp for a free demo session. We offer on-site and online tuition.
Question number 2. Solid A is impure calcium carbonate. A student determines the number of moles of calcium carbonate in a sample of A. Part A. The student places the sample of A into a beaker, uses a measuring cylinder to add 100 centimeter cube of 0.25 mole per dm cube hydrochloric acid HCl to the beaker. Stirs the mixture until no further effervescence is observed. Labels the mixture B. Calculate the number of moles of HCl added to the beaker. Now, you have to use this information. We know that 1 dm cube is equal to 1000 centimeter cube. So we can write 1000 centimeter cube contains 0.25 moles. Therefore, 100 centimeter cube contains X moles. So X becomes equal to 0.25 will be multiplied by 100 and divided by 1000. So the answer, you will get 0.025 moles. Part B. The student rinses a bead with water and then with 0.1 mole per dm cube sodium hydroxide NaOH. Fills the bead with 0.1 mole per dm cube NaOH, adds 25 centimeter cube of B and 5 drops of methyl orange indicator to a conical flask. Adds NaOH from the bead to the conical flask until the methyl orange indicator just changes color. Repeats this titration 2 more times. Figure 2.1 shows the initial and final bead readings for titration 1. So we have values. For initial, we are having 2.1234, 2.4 centimeter cube. And for the final one, we have 18.1 centimeter cube. Table 2.1 shows some of the students' results. 1. Complete table 2.1 by writing the initial and final readings for titration 1, calculating the volume of NaOH used in each titration, taking the best titration results. So final bead reading and initial bead reading for titration 1 is finally we are having 18.1. I've just written, and 2.4 for the initial reading. If you will find the difference for this one, what you will get? You will get 15.7. What about titration 2? 15.4 minus 0.2, you will get 15.2. Titration 3, 30.8 minus 15.4. It must be 15.4. Now you have to take the best titration results. You see the difference between the second and third one. These will be the best titration results. The reason is that in titration 1, the student added a larger volume. You see the difference between the volumes. In titration 1, the student added the larger volume. So definitely 5.2 and 5.4 will be the best titration result. Now you have to use the best titration results to calculate the average volume of NaOH used. For this one, for this you have to add these two, 15.2 plus 15.4 and divided by 2. You will get 15.3. C. The student used in A to prepare mixture B is in the acid used in A to prepare mixture B is in excess. Use your answer to B2 to calculate the number of moles of 0.1 mole per dm cube NaOH that react with 25 centimeter cube of B. So We have a volume of NaOH 15.3 and the concentration of NaOH, which is 0.1 mole per dm cube. So I'm going to write 1000 centimeter cube contains 0.1 mole. Therefore, 15.3 centimeter cube contains X moles. To the cross, we get X is equal to 0.1 multiply by 15.3 divided by 1000. And the answer must be 0.00153 moles. D. Calculate the number of moles of NaOH that react with 100 centimeters of B. You see the volume taken here? 25 centimeter cube. They have taken the 25 centimeter cube. So look at the relationship. So what I'm going to do? 25 centimeter cube. 25 centimeter cube contains 0.00153. 25 centimeter cube reacts with 0.00153 moles. So 100 centimeter cube reacts with X moles. So X is equal to 0.00153 multiplied by 100 divided by 25. So answer must be 0.00612 moles. The answer to D is equal to the number of moles of HCl that remain in the beaker after the acid reacts with calcium carbonate in the sample of A. Use your answers to A and D to calculate the number of moles of HCl that react with calcium carbonate in the sample of A. So we need to find the difference between the moles in order to find the number of moles that actually reacted with calcium carbonate. So we have A and D. Where is A? Here is A. 0.025. We need to subtract this value. 0.025 minus 0.00612. And you will get 0.0188 moles. F. The equation for the reaction between hydrochloric acid and calcium carbonate is shown. Calculate the number of moles of calcium carbonate in the sample of A. So we have HCl and CaCO3. According to the reaction equation, 2 moles react with 1 mole. Therefore, 0.0188 mole react with X mole. So X is equal to 0.0188 multiplied by 1 divided by 2, and you will get 0.00944. G. In A, the mixture of A and acid is stirred until effervescence stops. 1. Give a reason for mixing the reactants by stirring. Definitely to make it dissolve quickly or react faster. To make it dissolve quickly or react faster. Part 2. Give a reason for waiting for the effervescence to stop to make sure the reaction is complete. To make sure that the reaction ceases or is complete. H. In A, measuring cylinder is used to add 100 centimeter cube of 0.25 mole per dm cube HCl to the beaker. Explain why using the measuring cylinder makes the volume of HCl used inaccurate. Suggest an improvement. Measuring cylinder has lower accuracy. So best choice will be the billet or pipette. Billet is the best choice. Measuring cylinder has lower accuracy. That is only reach to 0.5 centimeter. You are adding approximate volume for this one. Okay, for improvement, you can use pipette or burette. Burette is the best choice, remember. In B, the burette is rinsed with water and then with 0.1 mole per dm cube NaOH. Explain why the burette is rinsed with sodium hydroxide after rinsing with water. So if you will not wash it with water, what will happen? There will be dilution of NaOH and this will definitely affect the titration results. To prevent dilution of NaOH. So question number 3. A student tests two aqueous solutions W and X. A1. The student adds aqueous chlorine to W and concludes that W contains iodide ions. Describe the observation that the student makes that leads to this conclusion. Explain how this shows that W contains iodide ions. So recall the position of these two, chlorine and iodine in the periodic table. It's in group 7. Group 7, we are having chlorine, chlorine, bromine, iodine, astatine, and tennessine. And you know the reactivity decreases down the group, which means that the halogen, these are halogen top of the group will be able to displace the halogen below it. So we are passing chlorine to solution containing iodide ions. Chlorine is more reactive than iodide. It will definitely going to displace iodine from this W. So what will be the observation? Observation will be due to the formation of this iodine solid or solution. So we'll get red-brown solution. Either we get red-brown solution or black solid obtained. For the observation, what you're going to refer to the positions of Cl and iodine from the periodic table. What you're going to write? You write chlorine displaces iodine. Chlorine has displaced iodine. Part 2, describe another test and the observation that confirms that W contains iodide ion. Now look at this qualitative analysis list. This is for the iodide ion. It's anion. So you have to acidify with dilute nitric acid and then add aqueous silver nitrate. Yellow PPT will be obtained. So what you're going to write? Acidify. The test will be acidify with dilute nitric acid and add aqueous silver nitrate. Observation will be yellow PPT obtained, yellow precipitate obtained. Part B, the student does a flame test on W and observes a lilac flame. Describe how the student does the flame test on W. They are asking about the procedure to perform this flame test. You simply have to dip or soak clean splint of wire in W. Dips or soaks clean splint or wire in W. Place it in blue or roaring flame. You can also perform it by taking W in spray bottles. They perform the whole step again for this. The difference is that just spray the W and you will see the difference that you will observe the color. And lilac flame, it's for potassium ion. So you'll definitely have the salt must be potassium iodide or Ki. They are asking identity Ki or potassium iodide. Move to next part. Next question. Next part. That's part D. X contains one anion and one cation. The student adds aqueous sodium hydroxide to X in a test tube, warms the mixture, holds a piece of damp red litmus paper above the test tube. A white precipitate soluble in excess aqueous sodium hydroxide is formed. The litmus paper does not change color. State three conclusions that are made from these observations. Now see, they are saying a white precipitate soluble in excess aqueous sodium hydroxide is formed and the litmus paper does not change color. This needs the test for cations. We will look at the test for the cations. We will look at the test for cations. We'll find Al3+ and Zn2+. Both of these will give white precipitate, which are soluble in excess, form a colorless solution. And for the litmus test, it must be of NH4. If NH4 positive ion is there, it will definitely turn red litmus paper to blue. That is due to the formation of ammonia. So these will be the observations, conclusions that X may contain Al+3 or Zn+2 ions. You can also write the name of the ions if you want. Then NH4 positive ions absent. Part E. The conclusions in D identify cations that may be present in X. Describe another test that the student does and its observations to identify the cation in A. So in order to confirm the presence of the cation, we have to perform another test, that is aqueous ammonia. You see, for the aluminum, the white PPT obtains insoluble in X, and for Zn2+, here's Zn2+, white PPT obtained soluble in X. So we must be having this aqueous ammonia solution test. So what you're going to write, add aqueous ammonia until in excess. Add aqueous ammonia until in excess. For observation, mention the observation for both aluminum and zinc ion. So for Al+3, form white precipitate. And you have to write further, insoluble in excess. I will show you to you again. If you look at the list, see for aluminum, it's insoluble in excess. For Zn+2, it also forms white precipitate. The only point is that it's soluble in excess. Again, I'm going to show it to you. Look at this. It's soluble in excess. F1. The student adds excess aqueous sodium hydroxide to X. then adds a piece of aluminum foil and warms a mixture. Ammonia gas is given off and tested with damp red litmus paper. Describe what happens to the litmus paper. You see ammonia gas given off. It must be the test with anion. You see the list. Here's the list. It's a test for the anion. And this test is for the presence of the nitrate ion. You are adding sodium hydroxide and aluminum foil. And if you warm it, you will get ammonia produced, which gives a test with damp red litmus paper. So what will happen to the damp red litmus paper? It will turn to blue. So you write turn to blue. Now, what they are asking in part 2, identify the anion and NX, it's nitrate or NO3 minus NO3 minus. You can write the name of the anion. Now, question number 4. Use a mixture of solid magnesium oxide and solid barium sulfate. Magnesium oxide is insoluble in water. It mixes with dilute hydrochloric acid to make a solution of magnesium chloride. Barium sulfate is insoluble in water and does not react with the dilute hydrochloric acid. Plan an investigation to obtain pure magnesium chloride crystals and pure barium sulfate solid from Q. Your plan should describe the use of common laboratory apparatus, dilute hydrochloric acid, and other chemicals should be used. Your plan should include the apparatus needed, the preparation of magnesium chloride solution, the method to obtain pure magnesium chloride crystals, the method to obtain pure barium sulfate solid, how to test that the barium sulfate is pure. You may draw a diagram to help answer the question. The total mark for this question is 6. So what you're going to do? So they are saying you have to include in your answer the apparatus needed, preparation of magnesium chloride solution, method to obtain pure magnesium chloride, method to obtain pure barium sulfate, how to test that barium sulfate is pure. These will give you 5 points. 1, 2, 3, 4, 5. So you can give 1 mark from each section and another mark from one of these. What I suggest you try to gain 2 marks from this one. Try to gain 2 marks from this. This is very easy because they have already mentioned you may draw a diagram to help answer the question. So you can draw diagram of 2 apparatus and straight away you're going to gain 2 marks. So gain 1 mark from each section. Gain 1 mark from each section and 1 other mark. So for the apparatus, if you look at this, the details given in the question, what apparatus you expect you will be using, as you are having one of the product obtained in this is insoluble in water. Barium sulfate is insoluble in water, so definitely you need filter funnel for this. So for the apparatus, I'm going to write apparatus filter funnel and filter paper. Mention the name of the container. You can use a container like beaker or conical flask. Container like beaker or conical flask. What else is needed? If you look at this, we need to heat also. We need to heat also in order to get the crystals of the soluble salt. So for this purpose, you need a Bunsen burner. Bunsen burner. Marking key suggests you can even use or heater or water bath. So if you know how to draw this heater or water bath, that's good. Otherwise, Bunsen burner, you can draw Bunsen burner. Then you are also having melting point apparatus. Again, this needs some knowledge of drawing these. apparatus. For your convenience, I am drawing the simple apparatus like filter funnel, beaker, conical flask, and Bunsen burner. I'm going to gain 2 marks by drawing any two of these. For example, look at this. So you have all the apparatus. Name it. This is filter funnel. This is conical flask. This one is beaker. And the last one is Bunsen burner. So you can gain straight away 2 marks by drawing any two of these. For the next 4 marks, how are you going to prepare preparation of magnesium chloride solution? Prepare MgCl2 or magnesium chloride solution. How are you going to prepare? You have to add HCl to Q. To Q, you can even write to mixture. Mention excess acid use. You can even write excess acid is used. For the next mark, how you're going to obtain magnesium chloride crystals? Obtain magnesium chloride crystals. Remember, it will be obtained as filtrate as it is soluble. So what you're going to do, you have to evaporate or heat the filtrate. Evaporate or heat the filtrate until half of the water is evaporated. You know that you can't evaporate it all. You have to leave some water for crystallization. Or you can write crystallize or leave to cool. Same meaning. How are you going to obtain barium sulfate solid? Obtain barium sulfate solid. It's insoluble. It will definitely be obtained as a residue on a filter paper. So you write filter Q after adding acid. Filter Q after adding acid. Or you can write wash the residue with distilled water. With distilled water. Or you can write dry the residue. Dry the residue after filtration of magnesium chloride. We are still left with one mark. That is how you're going to test purity of barium sulfate. Test BaSO4. BaSO4 is the formula of barium sulfate. BaSO4 purity. How we are going to do this? Simply measure and compare the melting point of the residue. Measure and compare the melting point of the residue. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.